In this video, we are going to look at the derivatives of trigonometric functions. So let's start by looking at the derivative of the 6 fundamental trigonometric functions. Number 1, the derivative of sine of x with respect to x is equal to cosine of x. Number 2, the derivative of cosine of x with respect to x is negative sine x. Now, we can use these first two formulas to reason out the derivative of the remaining 4 trigonometric functions. And I'll show you what I mean. Number 3, suppose I want the derivative of tangent x with respect to x. Well, I know that tangent of x is sine of x over cosine of x. So if I want the derivative of tangent x with respect to x, that's the same thing as the derivative of sine of x divided by cosine of x with respect to x. Now, don't forget, we have the product rule and the quotient rule, in fact. So in this number 3, I'm going to apply the quotient rule. So I'm going to write down the bottom function, which is cosine of x, and I'm going to take the derivative of the top function, which in this case will be cosine of x. I'm going to go minus the top function, which is sine of x, and I'm going to multiply by the derivative of the bottom function with respect to x, which is negative sine x. And I'm going to take that quantity and divide by cosine squared x. So this is cosine squared x. And remember, a negative times a negative is a positive. So we're going to go plus sine squared x divided by cosine squared x. But cosine squared x plus sine squared x is equal to 1. So this is 1 over cosine squared x. Now, 1 over cosine squared x is equal to secant squared x. And so therefore, the derivative of tangent x with respect to x is equal to secant squared x. Let's take a look at number 4. Suppose I want the derivative of cotangent x with respect to x. But that's the same as the derivative of cosine x over sine x with respect to x. And we can apply the quotient rule here. So I'm going to write down the bottom function, which is sine x, and then I'm going to take the derivative of the top function, which in this case will be negative sine x. I'm going to go minus the top function, which is cosine x, times the derivative of the bottom function, which in this case will be cosine x. And I'm going to take that whole quantity and divide by sine squared x. So this is negative sine squared x minus cosine squared x divided by sine squared x. And so from here, I'm going to factor out a negative. And when I do, I get sine squared x plus cosine squared x in parentheses. And then I divide by sine squared x. But sine squared x plus cosine squared x is 1. And so I get negative 1 divided by sine squared x which is negative cosecant squared x. And so therefore, after all that work, the derivative of cotangent x with respect to x is negative cosecant squared x. Okay. Number 5. So let's take a look at the derivative of secant x with respect to x. So this is the derivative of 1 over cosine x with respect to x. Remember, we don't have the chain rule yet, so we're going to use the quotient rule to find the derivative of secant x with respect to x. So the bottom function is cosine x. The derivative of the top function is 0, because remember, that's just a constant. Minus 1 times the derivative of cosine x with respect to x, which is negative sine x. And I'm going to divide by cosine squared x. So this is sine x divided by cosine squared x, which is sine of x over cosine of x times 1 over cosine of x. Okay. Now, let's take a look at this. Sine of x over cosine of x is equal to tangent x. 1 over cosine x is equal to secant x. So, therefore, the derivative of secant x with respect to x is equal to secant x tangent x. Okay. Now, let's take a look at one more derivative, and that's the one for cosecant x. And we can go through it again. So notice how that's the derivative of 1 over sine x. Okay. So I'm going to write down the bottom function, which is sine x. I'm going to multiply by the derivative of the top function, which is 0. Minus 1 times, right, that's the top function. The derivative of sine x is cosine x. And I'm going to divide by sine squared x, which is negative cosine x divided by sine squared x. Now, negative cosine x over sine squared x is equal to negative cosine x divided by sine of x times 1 over sine of x. These two mean the same thing. Now, 1 over sine of x is equal to cosecant x. Cosine x divided by sine of x, right? I haven't forgotten about that negative, okay? This is equal to cotangent x. Therefore, the derivative of cosecant x with respect to x is negative. And if you don't mind, I'm going to write it this way. It's negative cosecant x cotangent x. So you notice we were able to find the derivative of the remaining 4 trigonometric functions just knowing the derivative of sine x and cosine x. Now, with that, let's take a look at some examples. In these examples, the functions that I choose will involve trigonometric functions. Okay? Now, suppose I give you f of x is 3 sine x minus 2 cosine x. Okay. And I want to find f prime of x. Okay? Now, we've already gone over this. The derivative of sine x with respect to x is cosine x. So the derivative of 3 sine x with respect to x is 3 cosine x. I'm going to go minus 2 times the derivative of cosine x with respect to x, which is negative sine x. And remember that a negative times a negative is a positive. So when I simplify this, I get 3 cosine x plus 2 sine of x. And this is equal to f prime of x. It's very important. You told me that you're taking the derivative. So that's the final answer for example 1. Let's take a look at example 2. If I give you f of x is tangent x minus 4 sine of x, and I want f prime of x, well, the derivative of tangent x is secant squared x. The more you use it, the easier it will become, right? The more you write down the derivative of tangent x with respect to x, you'll start to know them more and more the more you practice, okay? And then the derivative of sine x with respect to x is cosine x. So the derivative of 4 sine x with respect to x is 4 cosine x. I'm done. That's the answer to example 2. Example 3. Suppose I had f of x equals x squared plus cotangent x. And I want f prime of x. Well, the derivative of x squared with respect to x is equal to 2x. The derivative of cotangent x with respect to x is minus cosecant squared of x. And that's example 3. Example 4. Suppose y equals 2 secant x minus cosecant x, and I want y prime. The derivative of secant x with respect to x is secant x tangent x. So this is 2 secant x tangent x, because I have a 2 out in front. And then I'm going to go minus, and then in parentheses, the derivative of cosecant x with respect to x is negative cosecant x cotangent x. And so if I go to simplify, I get 2 secant x tangent x plus cosecant x cotangent x. And again, this is y prime. And that right there is example 4. Let's take a look at example 5. suppose h of theta is equal to theta squared sine theta. And I want to find the derivative. So this is a classic product rule. So we're going to write down the first function, which is theta squared. I'm going to multiply by the derivative of the second function with respect to theta. So in other words, I'm going to multiply by the derivative of sine theta with respect to theta. And I'm going to go plus sine theta times the derivative of theta squared with respect to theta. So this is theta squared, and then the derivative here is cosine theta plus sine theta times 2 theta. Now, what I'm going to do here is factor out a theta. And when I do, I get theta cosine theta plus 2 sine theta inside the parentheses. And that, again, is equal to h prime of theta. That's example 5. Let's take a look at example 6. Suppose g of x is equal to 3x plus x squared cosine x. And I want to find the derivative. Well, the derivative of 3x is just 3. So that one's okay. But to take the derivative of the second term, it requires the product rule. So I'm going to write down an x squared, and I'm going to multiply by the derivative of cosine x with respect to x. I'm going to go plus cosine x times the derivative of x squared with respect to x. So this is 3 plus x squared times negative sine x plus, right? That's the derivative of cosine x. And then plus cosine x. And then the derivative of x squared with respect to x is just 2x. And so I'm going to simplify this a little bit here. G prime of x is equal to 3 minus x squared sine x plus 2x cosine x. And that's how we do example 6. Let's take a look at example 7. Suppose I give you y equals secant theta tangent theta. And I want y prime. Again, product rule. So I'm going to write down secant theta and multiply by the derivative of tangent theta with respect to theta. Plus tangent theta times the derivative of secant theta with respect to theta. So y prime is secant theta times the derivative of tangent theta with respect to theta is secant squared theta plus tangent theta times, and the derivative of secant theta with respect to theta is secant theta tangent theta. Okay? And so it is okay. You can factor out a secant theta because that's common to both terms. And when I do, I get secant squared theta plus tangent squared theta. And this is equal to y prime. And no, that is not a trigonometric identity. So we want to be careful there. So that would be example 7. Let's take a look at example 8. Suppose y equals sine theta cosine theta. Remember, we don't have the chain rule. Not yet. So we can't simplify that just yet because we don't know the chain rule. Again, I can't stress that enough. So I want y prime. Again, product rule. So I'm going to write down sine theta, and I'm going to multiply by the derivative of cosine theta with respect to theta, plus cosine theta times the derivative of sine theta with respect to theta. Okay. Now, this is sine theta times negative sine theta plus cosine theta times cosine theta. Now, cosine theta times cosine theta is cosine squared theta. So if you don't mind, I'm going to write it in a particular order. And then sine theta times negative sine theta is minus sine squared theta. But that is a trig identity. We can say that y prime is equal to cosine of 2 theta. So again, this is a trig identity. Cosine squared theta minus sine squared theta is equal to cosine of 2 theta. That's example number 8. Let's take a look at example 9. Suppose f of theta equals theta minus cosine theta times sine theta. Okay. Now, if you don't mind, when I take the derivative, I'm going to talk more through this one, as I more so than in the previous examples. So we're going to write down the first function, which is theta minus cosine theta, right? I'm going to multiply by the derivative of sine theta with respect to theta, which is just cosine theta. So I hope that's okay. First function, derivative of the second, multiplied together, plus sine theta, that's the second function, and then I'm going to multiply by the derivative of the first function, which in this case is 1 minus, and then the derivative of cosine theta with respect to theta is negative sine theta. Okay, but we need to simplify this. So this is theta cosine theta, applying the distributive property, minus cosine squared theta plus sine theta times 1 plus sine theta, right? Which is equal to theta cosine theta minus cosine squared theta plus sine theta plus sine squared theta. So I'm going to do one more step here for you. I'm going to write theta cosine theta plus sine theta. Now, I'm going to look at the second and fourth term, and I'm going to factor out a negative. And when I do, I get cosine squared theta minus sine squared theta in parentheses. But again, I could write that in a different way. So I can say f prime of theta is equal to theta cosine theta plus sine theta minus cosine 2 theta. And that was example 9. And I want to give you one more for this video. And we'll call this example 10. In example 10, suppose I had the following. F of x equals e to the x sine x plus cosine x. And I want to find the derivative. The first term requires the product rule. So I'm going to take e to the x and multiply by the derivative of the second function, which is cosine x. I'm going to go plus, and then I'm going to write the second function and multiply by the derivative of the first function, which again is e to the x. And then the derivative of cosine x with respect to x is minus sine of x. And so this is e to the x times cosine x plus sine of x minus sine of x. And this right here is f prime of x. And then incidentally, f prime of theta is theta cosine theta plus sine theta minus cosine 2 theta. That's the answer to example 9. And so this is a video on the derivative of trigonometric functions, and we looked at the derivative of the 6 fundamental trigonometric functions along with 10 examples. So I do hope this was helpful. All right, thank you.